Okay, here we go. A couple notes today. Okay, we are talking about the trig functions one more time, but we're moving on to a new section, which is section 4.5. We're doing the trig functions. Okay, trig functions with obtuse angles.
Wait, Mr. Wayne, can we race the beta fish?
Okay.
No, they'll kill each other.
Alright.
Yeah, that's fine.
Okay, hey, here we go. Alright, so for the trig functions themselves, the big thing is, I want to talk about, refresh your memory on, SOHCAHTOA. Talk about, the little acronym that we've been using. Talk about, the types of problems that they could throw at you, and kind of refresh on how you need to do your homework. We do need to talk about, co-functions and other things like that today, because that was something that we threw in there that was new last time. I want to talk about the reciprocal functions. And the big thing about today is I do want to talk about the inverse functions. So we've had a lot of types of functions that you need to know, you need to have them separated in your head. On Friday, we introduced the special triangles. The special triangles, there were two types. Those are something we need to review today because those will most definitely help us. I'll explain what we're going to be doing. And this is going to be pretty easy. Now I'm mixing section 4.4 and 4.5 together. But I think it's pretty straightforward once you see it. But that's what we're going to be doing. And then the goal is after we do a bunch of examples of these, I want to make sure that you are comfortable with the homework, and I'll give you the homework and I'll let you kind of work today. But I want to do roughly about 15-20 minutes worth of notes and give you about 20 minutes to work. Roughly. Okay? Maybe not exactly 20 minutes, but I want to go through the notes as fast as I can. So have your notes out. Let's write a couple things down. Here we go. SOHCAHTOA. Okay, remember, this acronym is just a simple way of remembering the formulas. Okay? That's all I want to review with you. Hey guys, we gotta stay quiet today. I can't stand the chat today. So, alright, sine, cosine, tangent, these are my three trig functions. The big thing is no matter what angle you have, you can always set up these trig functions. So the big thing is, let's talk about SOHCAHTOA itself. If they gave me let's say a 30-degree angle, and I want to do a certain trig function of that angle. I know we're not into obtuse yet, I'll show that in a minute. But let's say they wanted cosine of 30. Okay? And they wanted the exact answer of it. I know that's one of your first homework problems you had. Okay? Alright. The big thing that I want to make sure of, just put it on my desk please. Okay? The big thing I want to make sure of is how do you find the cosine of 30 is you have to set up that special right triangle, which is the 30, 60, 90 triangle. I don't care how you set it up. But the walls are very specific lengths. So this is the triangle. I think they have it printed in your book about the homework problems. The side opposite of 30 is 1. The side opposite of 60 is root 3. The side opposite of 90 is 2. What?
Why can't it just be double?
What do you mean?
Well,
What do you mean double?
is twice as large.
Oh, because of the Pythagorean theorem. It doesn't work that way. It's not a direct linear relationship. Like if they double an angle, it would double the wall. It's not that. Because the trig functions, which we're going to see in the later sections, they're actually curves. It's not like linear. If it was linear, when you like double the angle, it would double something. Right? It would double the wall, but we're not in that. These are actually based on curves, which is something we're going to look at the last sections. I think it's like section 4.6, 4.7, 4.8. It would definitely answer your question. You'll see that here in a little while. It's a good question though. Now, the actual cosine, the cosine of 30 is, if you look at this little acronym, it means the adjacent over hypotenuse. That's what A and H stands for. So this is the adjacent wall over the hypotenuse wall. That's what cosine of an angle stands for, cosine of theta. Okay, your theta in this case is 30. This is the adjacent wall to 30. It's the wall that's closest to it. And the hypotenuse is always the same. The hypotenuse never actually switches. Okay? The adjacent wall can. The reason why the adjacent wall can switch, it depends on what angle you're talking about. Okay? So, what is my adjacent wall to 30 right now? Root 3. The hypotenuse is 2. That's my answer I'm looking for. That's the exact answer. I don't want a decimal of it. I want that answer. all the results for these functions were that, I think in your book they were asking for, find certain ones like cosine of 30 or add it to the cotangent of 60, something like that. I know that was one of them. It was like cosine of 30 and you had to add it to the cotangent of 60. I know that was one of them, or something like that. You had to find each answer. Well, this is root 3 over 2, right? We just proved that. You had to add that to the next one. Well, the cotangent of 60, you have to look at the labels now. So for 60 degrees, now I'm doing the second one here, cotangent. Cotangent of 60, that is the reciprocal function. That's the reciprocals of tangent. So if I think about what tangent stands for, tangent of an angle is opposite over adjacent. Opposite over adjacent. So for mine, since I'm doing cotangent, I flip those over. That's what a reciprocal means. So it's adjacent divided by opposite. So for me, if I'm doing 60 degrees for cotangent, for 60 degrees, this is the opposite wall, this is the adjacent wall. Does that make sense? Like where the opposite and the adjacent are compared to 60? And then you have to plug those numbers in. The opposite wall for 60 degrees, cotangent of 60, is the root 3. That goes on the bottom. So this one is going to be root 3 on the bottom and a 1 on the top, because that's the adjacent wall. Does that make sense? Like adjacent over opposite for 60? Like where the numbers come from? Now, if I'm going to add those together, you have to get common denominators, simplify it. If I was going to do this, I would get rid of the radical off the bottom. Let's make this root 3 over 3. That's the same thing. And then I would get common denominators and add these together. So I would multiply this one by 3, multiply this one by 2. So I get 3 root 3 over 6. This is 2 root 3 over 6, and I can add that together, and that would give me 5 root 3s over 6. That would be the answer, the exact answer. That's what the book is looking for. That could actually be one of your homework problems. Okay, questions with how those first ones work. Now, obviously, we haven't had to deal with the obtuse angles yet, because the new section I said we're going into is, can we do the trig functions for obtuse? Because obviously, we don't have weird obtuse triangles, right? We don't. These are the only two special triangles we have. We have 30, 60, 90, which is this one. And again, the labels of that triangle change depending on what angle you're using. And again, the picture can be drawn differently in the book. You just have to look at what's opposite, what's adjacent to whatever angle you're dealing with. But again, the two types of triangles they're going to give you are the 30, 60, 90 triangle, which I'll draw again here. 30, 60, 90, which is root 3, 1, and 2. And then the 45, 45, 90 triangle, which I believe they have printed in the book, that one as well. That's 1, 1, root 2. Okay, we good? Alright, now, I talked about the reciprocals, how you can find them. Let's talk about cofunctions. Stop talking, I can hear you. Alright, so let's talk about a cofunction. A cofunction, this is something that I introduced Friday, so this is brand new. A cofunction is when they give you an angle, like let's say they want to find the cosine of 27 degrees. Okay, but they want just a cofunction. What a cofunction is something you could type in your calculator and it would give you the exact same decimal on the screen. Okay, so every trig function has a cofunction, not a reciprocal, not an inverse, a cofunction. So cosine is paired with sine. That's a cofunction. They always come in pairs. Okay, and how you do this, you always take 90 degrees and you subtract 27. That's how you find a cofunction. So the cofunction that would give you the same result on a calculator would be the sine of, what is that? 70, that's 63 degrees. That would be the same result on the calculator.
Can you go the other way around?
Okay, and you can go the other way. So if I give you the sine, you can go to cosine. Okay?
How about tangent?
Tangent?
Cotangent.
Tangent is actually paired, so let's say I give you tangent of 20. That's paired with cotangent. So this is the only trig function that's actually paired with its reciprocal. So the tangent of 20 would give you the same result as 90 minus 20, which is the cotangent of 70. So if you actually had those buttons on your calculator, it would give you the same result. Now some people don't because you don't have the graphing calculators and stuff, but some people do. Okay? And then the other one would be secant and cosecant. Secant, let's say 30, it would be paired with cosecant, and you take 90 minus 30 again, and that would give you the cofunction. Again, all these are, is it would give you the same result on the calculator. Now I know some people are like, well, Ward, why would you ever do that? Number one, the one time I've actually seen it used like correctly was on a test in college where the professor did a similar situation where we're not allowed to use calculators on the test, like at all. You had to do a whole trig function pre-calc test without any calculator in front of you. So I was like, how would that even be possible other than memorizing certain things? Well, they would give you the results of certain angles. Like above in like an answer key, above the test, they would have, the cosecant of 60 degrees. They had the decimal written down up top, and you could use that. So maybe on one of the problems, let's say there's a number 20 on the test, they had that thing written down. I was like, I don't know how to type that in. I don't even have a calculator in front of me. But if you did the cofunction, I have the answer. It's printed above the test. So I knew it if you knew what the cofunction was. It was one of those things they're testing your ability to memorize those formulas.
Was it hard?
No, it wasn't that hard. But you did have to know your trig functions really, really well. It was just one of those things. It was one of those intro pre-testing things. They were just trying to see if you knew what you're doing. So it wasn't hard. I mean, I don't think it was counted against our grade. It was just one of the things the professor wanted to see how we would do if you were taking a test like a kid would. Okay, questions on a cofunction. Now, what I would use that for, like the whole purpose of that, for me, like what I would use it, other than just a stupid test where you can find an answer, if your button on your calculator isn't working, like it isn't simply working, like you're pushing the sine button on your calculator and it's not doing anything, like the button's broken, you could do the cofunction and for cosine, and it would give you the same result. So that's kind of the cool part. I know that seems stupid because usually calculators don't work or they wouldn't fail you like that, but it is possible that you could use it that way. All right, questions with cofunctions, reciprocals?
No.
All right, the last one, in inverse. This, on your story problems that you had, like the homework problems that you had, there was a couple problems where they're asking for an inverse. It was something where they gave you I think there was a telephone wire, or telephone like pole, and then there was a cable going to it, and they were asking for the angle from the ground. It was asking for an angle of elevation. So let me give you the example here. And again, the whole reason why we're doing this is because we need it for the new section. We do need all these different setups. So if they have a telephone wire, so here's my telephone wire, right? And they had a cable going from the top to the bottom, and it wanted to know the angle of elevation to the top of that telephone tower. Okay, and it told me that the tower itself is 150 feet tall, and the cable itself is 240 feet,
Oh my.
and it wanted to know the angle to the top. Okay, so to set this up, I would label the triangle. So this is the opposite wall of my angle. This is the hypotenuse.
That's a big.
Opposite and hypotenuse, if I'm thinking about SOHCAHTOA, it's definitely this one. That's opposite and hypotenuse. That's the only one that's using. I'm not using the adjacent wall. So I'm doing the sine of theta is the opposite wall, which is the 150 over 240. And again, the labels would cancel. So you go away. Yeah, you chop these zeros off. You'd probably divide both by 3, so you get 5 over 8. Sorry, that's me. And the last thing is I would take the inverse sine to the other side. And this is called an inverse button. It's any time you want to find an angle, that's when you use the inverse buttons on your calculator. The sine of -1, okay, or cosine -1. It's whatever trig function you're dealing with. That's what this button is used for. It's just used to find an angle. It is not the same as cosecant. It's not a cofunction. It's called an inverse, and we use them to find angles. Now, there's one thing that we will discuss. That would be the later sections. In fact, Reese even brought it up earlier about the whole idea of like the walls doubling and whatnot. We're going to actually discuss like, can we guesstimate what answers are for something like that if you didn't have a calculator? That's something we're going to look at. I'm going to try to give you the best idea of that when we get to those later sections. So we're going to do like full circle, come back. Can we do some of this stuff without calculators anyway? But the sine of, the inverse sine of 5/8, I think on Thursday when we did that video lesson, I talked about, it's called an arc sine. It's just an inverse that they call arc sine when you're in college. But the inverse sine, so I hit the second key and I hit sine, so it gives me sine -1 on my calculator. 5 divided by 8, and I close the parentheses, and it tells me it's 38.7 degrees.
Why did you simplify? Why don't you just do 150 divided by
You can do that. I just,
divided?
yeah. So it would give you the angle for theta, 38.6.
Because it's easier.
Is it? Degrees. Okay, I think that was roughly the number I had.
Yep, I got 38.8.
Point
0.68.
yeah, 0.68.
218.
Okay, 1 or 2 decimal places. Do we feel comfortable with the inverse functions though?
Yeah.
Okay, now, the problem is, a lot of people don't know, like, why would you pick that function? That's why I labeled my triangle. That's why I label opposites and I label hypotenuses. I do label mine, I know that seems silly, but it tells me which trig function to pick and how to set it up. Okay? Now, our examples of the new notes today. So this is brand new. I want to talk about how can we use the same stuff we've learned, but apply it to bigger angles. Like 150s or 240s or a 210. How can we do angles like that with trig functions? How can I find exact answers, preferably without calculators? So, again, this is not like directing like we're not going to have calculators. It's just some people don't need a calculator when you get to these certain types of problems. So let me explain. Let's say that I want to find the answer. Okay, so let's say I want to find the answer for the tangent of 225 degrees. Okay, now obviously, that's a huge angle.
Yeah.
You know, my special triangles right now, they only go up to what the biggest is 60 and 90. I don't have a 225. So here's what you do. The first thing you do is you draw that angle in whatever quadrant it's in normally. So 225 is down here. It's in the third quadrant. You know, it's going from first quadrant
So you got subtract
all the way to here. Yep. And the trick is, what you do is you always bring it back to the x-axis, whatever the closest x-axis you are to. Okay? You don't go to the y-axis, you go to the x and you draw a triangle. This is how you do these problems. You're going to set up a triangle right here according to the x-axis. Now, instead of the 225, what you do is you take 225 and you subtract whatever axis you were closest to. So if it was like in the third quadrant, you would, or fourth, you would subtract like 360. That would be the closest x-axis. So if you're in the top, you'd subtract, from 0. If you're up here, the third quadrant, you subtract it from 180 because that's the closest x-axis number. So I would subtract 180 from this. And that number that I would give you would be 45 degrees. And that would be this angle that you have with in the third quadrant. Okay, what most of the time what the books do, and no matter what textbook you're in, they always give you nice pretty numbers. So if it's 45, I have the special triangle. It's a 45, 45, 90 triangle. So that's 1, 1, root 2. In fact, one of the numbers is negative. The number that's actually 2 numbers are negative on this triangle would be these 2.
That's a very negative triangle.
There's 2 walls that are negative. Because you're in the third quadrant, you're going over negative, down negative. If you think about like the quadrant system. Now, I know distances don't make sense to be negative, but in that quadrant, that would be how you get to that one dot. You go over -1, down -1. Now, the hypotenuse, this hypotenuse will always be positive. You have to make sure your hypotenuse is a positive number. Okay, no matter whatever quadrant you're in, it's got to be positive. And then you can set up your trig function. So maybe one's tangent. So we're going to do the tangent of 45 degrees. That will give me the same answer because what quadrant you're in. Tangent is opposite over adjacent. So if I were to take, because again, TOA, opposite over adjacent, the opposite wall is -1, and you're going to divide by the adjacent wall, which is also -1, so my answer is 1. In fact, on a calculator, the tangent of 225 is 1. That's the answer. Okay, questions on the obtuse things that we're going to be going into? Now, I've already taken more time than I wanted to today. I'm going to give you the rest of class day to work on your homework. That's your page 498. Okay, I'm going to give you time. It's due this Wednesday. Remember, if any of you borrowed calculators from me, I do want them back by this Wednesday. Okay? All right. Let me write the homework on the board, and the rest of the time it's yours.
I'll be so mad, Lars, if you can't get your calculator because you stole one this year.
Okay, here you go. Homework page 498. And again, it's on the board over there, but some people like to see it up here. Numbers 4 and 5, 10 through 20 evens,
That's Dalton Hawes.
30 through 33, 53 through 60 all. All right, there you go.
It's gonna get more
That's
artsy.
what I did this year.
It's gonna get more artsy. Wait, Mr. Ward,
Yes.
why don't you let Brian use that camera for you?